John, thank you for being here and joining Ed and I in a discussion about AEA and corn. It's super exciting. I've seen you talk a bunch of different times in a couple different Nexus events, and my brother and I came out to the event that you and Rick Clark did down there with Keith in in Indiana, right on the state line there, and rarely has it been, solely dedicated to say corn, where there's a lot of discussion about a bunch of different things. So I appreciate you spending some time with us today to talk about what you guys have going on and that being in a corn system.
Corn carries a lot of emotions for a lot of people. It's probably the one plant that has got more people addicted to it than marijuana, at
Yeah,
least in the sense of growing it and corn syrup.
guilty.
Yeah,
Yeah.
it's an honor to be here. Thank you for having me here, Andrew. I've been looking
Yeah,
forward to
yeah,
this
I,
chat.
I appreciate it, and we've done a bunch of different things with AEA and have growers that are incorporated AEA into their system, and I'd love to get your take on what some of that looks like, how we can improve a corn system with the use of whether it's AEA product or just an overall different approach in certain cases.
Yeah, give me a bit of context, Andrew. What have growers experienced, and what have the observations and the experiences been?
Sure. So Ed can key in on a little bit of this as well. Is we've had even on our own Discovery Farm where we've had some different AEA products and more specifically the BioCoat Gold as a seed treatment as part of our trial. And what I've seen is in situations across the landscape and in areas where either where people had it in a comparison to maybe an industry standard seed treatment, the overall plant health throughout the entire year, just from that start with the biological seed treatment, has just set us up for better success in the long run. In this past year, in areas where I had some serious issues with some rust across the certain areas, things just seemed to hold on a lot better if they were treated with biology.
Yeah, what have you been observing, Ed?
Well, similar to Andrew, so like over the last 5, 6 years, we've tested chemical seed treatment against untreated seed and biologically treated seed. And we've had some very stressful springs in there, cold. We like to plant early, deep. And the untreated seed or the biological treated seed is always better than the chemistry treated seed.
It's not
That
supposed to
doesn't
work that
happen.
way, though.
No, it's going to get 70 years of information, I think. So, I just took it for granted, and we started doing
Yeah.
some biology work, CRO work, and we started using our untreated seed that we developed and treated seed, putting different treatments on for people, and we started recognizing that our untreated seed was yielding better than treated seed. And so then we just kept exploring that. And it's been mind blowing to the point where in our brand, we don't even offer chemically treated seed anymore. It's either going out the door naked or, so farmers can do what they want for treatment or nothing, or we're putting on biology for them.
Yeah.
So that's the way we changed our business now because of that.
Wow, that's remarkable. It's remarkable to me that you've found the effect to be that systemic because I had assumed that even though I know of it's more than dozens, I can probably accurately say hundreds at this point, hundreds of experiences similar to the one you described, where growers tested naked seed and it outperformed the treated seed. But I had still assumed that surely there were some soils somewhere that were challenged enough that the seed treatments made sense, and probably there still are, but you just haven't uncovered them.
Well, we haven't really found a biological seed treatment that increases yield. But in the absence of let's say the problem, and then we're still maybe we're looking for that magic elixir, let's say. But the what we have seen is that the biological seed treatments that are out in the marketplace, including your BioCoat Gold and Seed Flare, are very defensive. And so we're seeing that they are probably better against those pathogens than the chemistry without doing the harm that the chemistry does to the other soil microorganisms.
Fascinating. So you have a defensive approach, a probiotic approach instead of an antibiotic approach, and you're finding it to be more effective. That's
Yes,
fascinating.
yes. And like I said, it's 5 years of seeing that. In the first couple, you always scratch your head, am I really seeing something that's real or not? And then it just consistently happens over reps and locations and years. You got to believe it's real.
That's fascinating. So what you're suggesting is that we should actually think about microbial inoculants in terms of resistance to soil-borne diseases rather than in terms of yield improvements.
I think that's the correct way to position it today. I still want to find the one with yield improvement yet, or what combination that is, if one exists.
Oh, it
But
does exist. We're working on
well, that's can you tell us? Sure.
it. Yeah, I can't tell you how quickly I can get you some to experiment with, but probably before planting.
Mhm. Yeah. No, that's exciting because we've added or really made a commitment to being in the biology world or soil health world or regenerative agriculture, whatever you want to call it. I mean, I've been a big ag guy for 40 years and I've had a conversion here now
Yeah.
where we're changing everything to how do we make the world healthier rather than cast out poisons. And
So I have a follow-up question for you on the yield response. If you've not noticed a yield response, what has the use of fertilizer or plant nutrition been in conjunction with that inoculant? Has it been, or with any of these inoculants, have they been reduced? I guess my question is, are you observing the same yields with less nutrition application?
so we're trying to tease that apart. I mean, the first because if we follow a scientific method as much as possible, but I'm getting too old to do it as good as we should do it. I start mixing combinations together that look better, so that may be useful, and then sometimes we end up tearing apart because it didn't work the way I thought. But what we I got to think about that. So we got all kinds of different trials going on at the same time to understand what's happening. So we're trying to look at seed treatments. We're trying to look at fertility. One of our big pushes is how do we reduce applied or synthetic fertilizers? And I can tell you that when we started adding cover crops or and biology, either independent or together, we're needing less nitrogen. Our discovery farm, so we are generally our testing program is basically on farmers' fields that they're cropping, the way they manage it. And so last year was the first year we just rented a piece of ground. We're going to farm it our way. And so this is our first time at teasing it apart, what happens when we do everything regeneratively. But as we go into different farms, we're going into different crops, sugar beets, corn, soybeans, wheat, whatever the farmer's been on, and we follow with our genetics and then our trials. And we're reducing I know I can reduce nitrogen now when we apply certain seed treatments, biological seed treatments, and if we have a cover crop in there. And the one thing that blew my mind this year is I ran all our genetics across cover crops, competitors' products, and with and without cover crops just to see what happened. It was I think 9 species mixed from green cover, and we worked with Keith and his team to figure out what would be low growing so it doesn't get in the way of our corn head, all the stuff you get nervous about. And we saw I believe it was a 7.9 bushel increase across the board on all hybrids. But the
And
rain with the cover crops.
with the cover crop being grown in the field at the same time as the corn, companion crops.
Yeah, interseeded at V3.
Wow.
But we saw a range from -18 to +34
Now,
on
hang on, Ed. This isn't supposed to work. You're supposed to have these plants competing for water and nutrients.
yeah, and the yield went up. Go figure.
I love it. I can explain how that works.
Well, that'd be awesome because it was just totally unexpected. It really was. And I I'm very enthused about what's happening when we see that. The field is beautiful. The only problem is that fall when you want to walk through and take notes, you got to watch out for the turnips. I may have to take those out because you can roll your ankle on the turnips when you're walking through the field.
Yeah.
So
So, did I understand you correct? Did you say you have seven species or seven different plant families?
we had 9 species and I think 5 plant families in that
Five
mix.
plant families.
Yes.
Yeah.
And
Awesome.
I'm convinced diversity is king on that. And then I also had, before we went into the season, I planted cereal rye and attempted to terminate it before I planted corn and didn't do very well. The herbicide I sprayed, we got a rainfall on it, so I had intermixed kill, let's say. Red Heart, all I did, I think, was irritate the cereal rye with the herbicide I applied, and so it was pretty strong. But I did have an in-roll crimper from Dawn that I used, and that saved my corn crop. It
Okay.
it, it did work. It beat it down enough so the corn could grow through it, and so that worked. I had to crimp it twice to get in front of it. So so this discovery farm is we're doing the mistakes the guy would do to convert his farm over. We're learning. I've been in the 2 years since I've had my conversion to soil health and regenerative ag. I've been watching about every YouTube and podcast I can listen to, and to try and put together all the things that people say are working from various parts of the world. And that's how we decide what we're doing. So I mean, it became very easy to say diversity's king. Cover crops are absolutely important. We're harvesting sunlight, so let's have a live root out there every day that that plant can grow. So that's our mantra right now.
Yeah, that is awesome. So I'm curious, do you have any perspectives? Your hybrids, where you tested this, you got yield responses across the board when they were grown in conjunction with companion cover crops. Um, do you have any perspective on how varieties other than your hybrids would fare in such a system?
So yes, so we had competitors checks in with ours, and we had a range from like a minus 18 bushels per acre with the interseeded cover crops to a positive 34.
Got it.
And what I find interesting is the genetics that did the best are the ones that we're seeing the most nutrient efficiency with when you use less synthetic fertilizers. So there's a lot of good interaction going on under the ground.
Wait, say that again. You're saying you're getting the best results when
So the highest, okay, so those hybrids that let's say were 20 bushel and higher
yep.
uh, over the non-cover interseeded cover crop, those same genetics are the ones that are responding positively to less applied synthetic fertilizer.
Uh-huh. In other words, they have a closer collaboration and a greater dependency on their microbiome.
Hmm. Yeah, so they're either bringing what they need to the party
Yep.
and finding it with the cover crops, or they're getting what they need from the cover crops from
Right.
the diversity of the biology.
Yeah, and John, to add on a little bit to what you had mentioned or you had asked before about, having it in a system where there is, say, it's an AEA program or something similar to that out there, is our nitrogen use efficiency is improving. So, guys are getting away from the 1.0 or the 1.1 or the 1.2 pounds per bushel, where we're seeing it, some extreme cases where there are guys that are using none. They might be limited in terms of what they might look for in terms of overall production, but their profit is still pretty darn good on those acres. To guys that are running a 0.25, so it's just things are becoming more efficient. That I see with my boots on the ground in those areas, as opposed to a full, say, commodity production specialist environment.
Do you have any perspective on what the lowest nitrogen rates are when you account for nitrogen credits coming from being contributed from a cover crop or something like that? Are you down to 0.65, 0.75?
It's hard to give an exact number on what that is. There's a lot of different factors that play into it. I think it would be irresponsible of me to say, yeah, we can run out there at a point 0.6 across every acre out there. But there are guys that are running at a 0.25 all the way up to a point 0.8.
Yeah.
And we've seen some hybrids have competitive yields, like over 200 bushel an acre at a point 0.3 and point 0.4. pounds of N that was in the soil residually from the year before or applied or in conjunction with applied synthetic. So that's probably the best that we've seen so far, but we don't know what the limits are yet.
Yeah. Well, I think the what you're describing, um, the limits that I've seen, the lowest that I've seen is um, all in, and this was considering the contribution of biology as well, was about zero point 0.5 to 0.65 pounds of N per bushel.
Hmm.
0.65 to 0.75 is actually not that difficult to achieve with
Right.
reasonable management with cover crop incorporation and microbial inoculants and so forth, which is a pretty substantial savings into this coming year, which could be pretty important for a lot of people.
Yeah, it definitely is. And uh, we it's very intriguing because we're also seeing a reduced requirement when you bring the soil health component in for less of the other macronutrients, the P and the K. We're seeing a reduced need for those. We still got to watch the micronutrients, so what we could be short on, because uh, as we test through the year and see what we had to, fully apply that to maintain productivity.
Yeah. Have you ever described on previous webcasts? Have you described for your audience the rhizophagy cycle? Would you like for me to dive in and describe why you have greater yields with companion plants than without?
Yeah, yeah, John. I've heard you talk about it, and I think that it's something that if there are people that are unfamiliar with it or looking at certain things differently, this is something that's super super important to understand. So yeah, if you want to dive in on the rhizophagy cycle and expand some minds, let's do it.
Yeah, I'll keep it straightforward because I love this exchange and just this conversation, and I'm sure folks will have questions that we can respond to as well.
Yep.
But in essence, the concept is that we we have to open our minds to a very different form of agronomy and plant nutrition. Agronomy for the last 7 or 8 decades has been framed almost exclusively, has completely ignored the microbiome component. It's been framed in terms of chemistry. And so plant nutrition has been communicated in the sense that plants absorb these water soluble nutrients from the soil solution through osmosis or through these various mechanisms. And so the idea has been that we have the absorption of nitrate ions and ammonium ions and potassium ions and calcium ions and so forth. And that process does work, but that's, after all, how plants absorb nutrients in a hydroponic setting. But it also carries all kinds of challenges. If you are dependent on nutrients that are in a water solution, what happens when the water disappears? Your nutrient availability also disappears. Or vice versa, if you have an abundance of water and you get nutrients leaving with the water. So there has been, throughout that entire 7, 8 decade period or longer, there have been individual pioneers who've repeatedly kind of raised the flag and said, hey, there is this other mechanism, there's this other pathway, there's this other approach by which plants absorb nutrients through their microbiome. And that has historically been ignored, but it was really brought together most recently by Dr. James White at Rutgers University in a very beautiful a very beautiful cycle that he described as the rhizophagy cycle. And so credit goes to Dr. White and his colleagues for this work. But there are now a number of people, number of scientists and microbiologists contributing to this work from around the world, and our understanding of how plants interact with microbes is just accelerating. So we understand that our own bodies, we have, I forget what the number is exactly, but we have like 10 times more bacterial cells within our bodies than we do human cells. And the same concept holds true for plants. Plants are colonized by microbes. They have these endophytic bacteria living in between the cell membranes. There is no location on the plant or within the plant that is not colonized by microbes, um, including inside the seed, where we have billions of microbes inside the seed. But what happens, and the reason this matters from a from a nutrient absorption perspective, is what Dr. White and his colleagues have described is that right at the growing root tip, the growing root tip exudes a high proportion of sugars of what the plant exudates total are right at the growing root tip. And so there is this culture, this cultured environment where you have very high bacterial concentrations as well as microalgae as well as fungi that are right at that growing root tip. And the growing root tip is actually porous to these microbes, and they are absorbed into the root tip, back into the root. And from that point, they migrate, they're transported through the plant's vascular tissue, as well as we're now discovering they even migrate between cell membranes very slowly. They colonize the entire plant from the nutrient, from these microbes that are absorbed from the roots. And then, when they get to a plant cell, what is fascinating is these microbial cells might contain different concentrations of nutrients. One might be higher in zinc, one might be higher in calcium, one might be higher in nitrogen. And when they get to the plant cell where the plant is growing or needs nutrients, the plant cells, given the opportunity to do so, there's some nutritional requirements that have to be in place in order for this to function well. But given the opportunity, these plant cells can be selective about which microbes they absorb. So they can proactively select, hey, I need more zinc or I need more calcium. They can determine which nutrients they absorb. Those bacteria then enter into that cell through a process called endocytosis. They essentially unload their load of nutrients and go back out through the cell membrane through a process called exocytosis and migrate back to, they have the ability to migrate back down into the root system. It's this beautiful process. But what is really interesting, these plants then send a chemical signal where they are communicating with their microbiome and saying, hey, I need more zinc, or I need more manganese, I need more phosphorus, whatever elements it needs more of. And the microbes that are in the soil profile will selectively extract more of a specific nutrient and transport it into the plant. And so far in this conversation, I've not talked about mycorrhizal fungi, but the mycorrhizal fungi also serve as a bacterial transport pipeline, where they are transporting bacteria that are loaded with nutrients from very distant locations up to yards away from where the plant roots are, and transporting them into the roots. And so this whole system is in communication, and when it's allowed to thrive and function well, then the plant can signal what its nutritional requirements are, and the microbiome will respond and supply those nutrients. Now, if you think about what I just said, that means that these plants should have less nutrient deficiencies. They should have lower nutrient imbalances. And I think that's part of what you are observing when this system is working well. But I want to go back for just a moment. There's a very important piece here. I haven't yet gotten to the most important part about why we have this yield response when grown in conjunction with cover crops. I'm going to get there. But first, I made a comment that these plant cells can be selective about what they absorb, and the root system can also be selective about what it absorbs, given the opportunity to do so. And this is kind of the nexus point of good agronomy from a biological perspective, and that is plants and plant cells can only be selective in the absence of excessive electrolytes. So if you have too many electrolytes, it degrades the cell membrane's capacitor potential. It degrades the voltage separation across the cell membranes, and similarly within the plant. So when you have excessive electrolytes, the plant has a limited ability to be self-determining. This process, we call this process homeostasis. So this homeostasis process, there's many different processes that are homeostatic. Our bodies regulating our body temperature is a homeostatic process. It means that our bodies will naturally turn the heat on or off depending on what environment we're in. It's a self-regulating process. Plants have the ability to absorb nutrients or to manage nutrient absorption through homeostasis to increase or decrease the absorption of potassium, for example, or nitrogen, for example, as long as their system isn't overloaded with excessive electrolytes, which is what happens when you fertilize with high levels of soluble nutrients. So the kind of this nexus point, I think one of the pieces that has really set us apart as a company at AEA is figuring out how to manage the off-ramp for soluble chemistry nutrients while simultaneously developing an on-ramp for biology. Because you kind of have this catch-22. You can't discontinue the use of fertilizers too abruptly until you're confident that the biology can deliver nutrients. And at the same time, in order for the biology to be able to deliver nutrients, you have to have less soluble electrolytes in the system. So it's managing the combination of those two of how do you manage, create an off-ramp for chemistry while creating an on-ramp for biology. And it's figuring out that dynamics within each ecosystem. That is where the magic happens. But let's get to the good part. How does this system, by the way, one of the pieces that I want to not lose sight of is all of these bacteria that move into plants. Bacteria are inherently very high in nitrogen. They're very high protein content, very narrow carbon to nitrogen ratio. And so you can deliver large amounts of nitrogen. In fact, I'm of the persuasion that you can deliver the great majority of a corn crop's nitrogen requirement through this rhizophagy cycle, through these corn plants absorbing bacteria from the soil. But, and the one other piece is that this process continues to happen in the absence of free soil water. So if you have soil that appears to be dusty dry, you can still have, and in that environment, of course, as you know, water-soluble nutrients are going to disappear and not be available, but you can still have bacteria moving through mycorrhizal fungi hyphae and into plants and providing nutrients, even in dry environments. And this is one of the interesting things that we've observed is that these biological approaches, if we have soils that are very wet and very saturated for a part of the growing season, then there are often not such significant differences between a biological approach and a fertilizer approach. But if you have dry conditions for an extended period, biology wins every time, usually by large margins. So whenever you have dry stress, you can have biology continuing to deliver nutrition, which gives you greater test weight and greater yield in those drought stress environments. Let's get to the fun stuff of quorum sensing. This is what's happening with when you have this diversity of different plant families as companion plants to a corn crop. So what happens with quorum sensing, Dr. James White has told us that we have each individual corn seed has between 7 and 9 billion microorganisms inside of it that is being vectored from one generation to the next. And so it is not just, when plants don't have this beneficial microbiome and they're planted into soil that does have that microbiome, they can recruit it to some degree, but that process takes time. The best solution, and the one that I'm optimistic that you're experiencing is we actually get that microbiome into the seed, or we band-aid it with a seed treatment, such as with BioCode Gold. But what happens, we know that each of these plants and plant species has it has its own microbiome that it has a symbiotic relationship with. And that species mix and species composition can look quite different across different plant families. So when you have a diversity of different plant families, so in your case, in the case of your cover crop mix, you had 5 different plant families, plus possibly corn might have been family number 6. And now you have 6 different microbiomes that are very different from each other. And what frequently happens in that environment is you engage this process called quorum sensing. So what is quorum sensing? Quorum sensing is when you have this group of organisms that begins behaving as one superorganism, and each individual species or microbe takes on a specialized function. So you may not be familiar with the language, but you're certainly familiar with the concept. The classical example of quorum sensing in a superorganism is a honeybee colony. A honeybee colony is comprised of tens of thousands of different individual honeybees, but they all behave as one collective superorganism, as if though they have one unified purpose. And each of the individual honeybees takes on a very specific function at different stages of life. You have nurse bees, and then you have guard bees and foragers, and they all take on these very specialized roles. And the same thing happens with microbes as populations shift. So as I understand it, there are kind of 2 different, this is a gross oversimplification, so bear with me, but there are kind of 2 different thresholds, if you will, of quorum sensing. The first one is when it's confined to a single species. So let's say that you get an infection of bacterial pneumonia, and in the early stages, when you have a few hundred or a few thousand individual cells, those bacteria all behave as individuals. And as each individual, they're responsible for everything. They're responsible for finding food and for protecting themselves and for reproducing. When the population builds, it reaches a certain threshold, a certain point. It becomes large enough that all of the individual cells begin communicating with each other, and they develop this quorum sensing community, and they begin behaving as one superorganism. At that point, the infection, if you will, or the population usually really accelerates, because now you have some cells that take on the specialized function of protection. So they start producing biofilms or mucus. Other cells are responsible for reproduction. Other cells are responsible for finding food. So they take on this very specialized function, and the overall community just proliferates very rapidly. So that's kind of, I'll say that's kind of the first stage of quorum sensing, is when it's confined to a single species in a very conducive environment. But then you have this second type of quorum sensing that is also a function of population dynamics. You need to have both enough population diversity as well as a large enough population threshold, when now that superorganism includes all the species in an ecosystem. Not just the microbes, by the way, but also the plants. So what happens, this was beautifully illustrated in it's now become a fairly popular anecdote of the cover crop research trials that were conducted at the Minokan farm in South Dakota back in 2012 and 2013. Jay Fear talks about this quite a bit. I've heard other people reference it. But they experimented with, if I recall the story correctly, there were 7 different cover crops that were planted individually and then in a combination block that included all of them in one. And in those two growing seasons, they had severe drought stress. The seven species that were planted individually, those seven different plots, for all practical purposes, you could just say they turned into toast. And the plot that had all seven species combined stayed green. There wasn't a lot of growth. They were 12 to 18 inches tall. So there wasn't vigorous, lush growth, but they were all green. They were all continued to photosynthesize, and they showed no visible examples or visual expressions of moisture stress. Now, how is that possible? How does that work? And what Lynn Margulis pointed out years ago is that the earlier simplistic thinking was that the evolution of species is really about survival of the fittest. But she pointed out, actually, it's not survival of the fittest. It's survival of the most effective collaborators. So we have gotten this thinking that we have to limit, that weeds are anathema because they are competing with the plants for water and nutrients. But what was illustrated in the Minokan farm plots and what has been being illustrated in your cornfields where you're doing these experiments is that these plants are actually begin collaborating with each other and they're connected by the microbiome. So the microbiome and the plants in that ecosystem all begin collaborating with each other, and they begin sharing water and sharing nutrients. But in order for that to happen, that only begins happening in our observation in most instances when you have enough plant families diversity. If you just have a corn crop and you plant Italian ryegrass into it, you only have a single family, and that single family, the Italian ryegrass, will compete with the corn. So you can have all kinds of different combinations. If you have just one or two different species, different plant families, then it's true, you do have competition in that environment because you don't have enough diversity to build quorum sensing behavior. So anyway, I've rambled on long enough, but this is pretty exciting because what this means, if you think about what I just said, the combination of the rhizophagy cycle plus quorum sensing means that as we build and optimize these systems, if plants are constantly signaling to the microbes exactly what their nutritional requirements are, and the microbiome has enough energy, enough sugar energy to go after it, it can supply the great majority of the plant's nutritional requirements. And I just came back from speaking to a group of nut growers in California, and several of them were describing how they had they'd been working with AEA, been working with different microbial inoculants and cover crops and doing different things. And all of a sudden, the nutrients that were in excess in their system coming from irrigation water, such as sodium and chloride and bicarbonates, they just dropped all on their own. They dropped very dramatically. And the nutrients that they never could get enough of, potassium, phosphorus, and so forth, calcium, because they were being bound up by these elevated sodium levels, they came up all on their own, simply from working with biology and building these microbial populations. So there's a lot more that I could talk about there, but I think I'll hit pause. I'd love to turn it over to you, Ed or Andrew. Like what have, as I've described this, what does this bring up for you? How do you think this fits into your observations?
Well, I will say one thing on the quorum sensing is that if there are people that are kind of understand or not understanding what it is or want to learn more about it, there's a phenomenal book that's out there that talks about now what's in trees, but finding the mother tree is a great book that talks about this program of quorum sensing and so it's a great read.
Let's,
Suzanne Simard
yeah,
is
it's a
the
great book.
author.
It's a
Yeah.
great book. I highly recommend it. And let me just take a minute to describe where the title originated, Finding the Mother Tree. The I'm sure I'll butcher the concept in her very beautiful and elegant explanation, but in essence, she was able to describe that if you have a seed that germinates from a mother tree at a distance of even up to a couple hundred yards, when that seedling emerges, if it is in a stressed environment, maybe it's in very thin soil or it's being shaded by other trees, if it is being stressed, the mother tree will support that daughter tree by sending sugars through the soil's mycorrhizal fungi web network and transfer it through this network also through trees and transfer it kind of this domino effect from tree to tree to tree. She was able to document getting sugar transferred through 6 intermediary trees all the way down to the daughter tree with none of those intermediary trees taking any sugar for themselves. Isn't that incredible?
Yeah,
That's
the
so
wood wide
cool.
web.
Yep.
Yeah. Yeah, it's amazing, and you see that. I mean, I believe that even in a monocrop situation, that we're still getting a some sense of quorum sensing that's going out there. I believe that it's easier achieved in a much more diverse setting for sure. Um, but overall, it definitely will lead to improved health of that entire field.
Well, it is a different state of being. It's a different state of being for that field and for that crop, and one which many of us haven't gotten to observe very often. But it just, the entire behavior changes, drought susceptibility changes, photosynthesis patterns change. Like just everything changes in some really beautiful ways because it is a different state of being when they are in synergy with their microbiome rather than in antagonism with their microbiome.
I'll tell you that when you're in a field that if it's a intercrop situation, or there's increased diversity that's added to a monocrop situation, the field feels different to me as a human when I'm walking around it. It sounds different. It feels more alive. And I think that all plays into it that maybe I'm being added into that quorum sense in a way.
Yep, absolutely.
Well, Ed, you can speak to it. At the Discovery Farm, some of the different life that's been that's come back into that field since we've taken over that ground.
Yeah, so we've only had it since the fall of 2024, and we planted cereal rye as soon as we got possession of it, right in the end of October, and from that point on, everything has been geared towards reduced synthetic chemicals and fertilizers applied. And so um, I maybe made a mistake with that farm and I didn't put on any phosphorus or potassium, but my agronomist at the co-op would have told me to put it on, but based on what I understood about it, I didn't need it. There was enough on there, so I thought I'd do the very sinful mining of the soil for my P and K and just apply nitrogen in reduced amounts. But with all that, um, the farm really, with the cereal rye and taking me some time to get under control, birds almost immediately moved in. And there was some CRP ground or some set aside ground around the farm, but it's like they moved out of there into our field for some reason. Pheasants and other, doves and other birds. It's like it almost instantly came alive. Every time I walked out there, I was chasing a bird around, and you could start to hear insects buzzing. And then as we got to about V3 or so with the corn, I put the cover crops in, then it became very diverse. Then the wildlife and higher order of insects started coming through, and you could just hear it buzz every time we went out there. And like Andrew said, I just felt like I walked into something that was truly alive because I could go about 5 miles to another field that we had the exact same hybrids planted or trials, and it was stone quiet out there. you know, and so you just know it's alive, and I've never experienced that before in all these years of doing research work, whether tropics or U.S. or globally or whatever, and I just found that fascinating, and even the landlord came out and talked to me one evening when I was out there, and he said, I've never heard this farm this alive before." And he was all excited about it. I mean, I met, we were in a church group together, and he knew I was looking for some land, and his young fellow that was farming had decided that he wasn't going to make it. and he was farming at the Big Ag Way, and he kept hearing me talk about our men's group about what we were working and on. He said, "Well, why don't you if you're interested, rent my farm and do it." And it's been a wonderful experience just to see that transformation. And of course, I don't learn lessons very well, so I went right back and planted cereal rye again this fall because I want to figure out if I can control it in corn or how do we do it. And so we'll see if I decide to move on and go to something like triticale or something else in the future. But I really like what live roots do in that soil, how it starts to transform it. So we've done our work in this farm doing the genomic testing to see what biology was out there so we can watch that transform. And really the biology that came back was the negative biology that you didn't want. And basically understanding the genetics that were planted there before from the genetic supplier that provided that brand with the genetics. I totally expected the diseases that, or the fungal and bacterial that came in that testing. And so we tested that soil 3 different times genomically, and our fungal to bacteria when we started was around 1 to 700 maybe bacteria, one fungal to 700.
Wow.
And I mean, so it was really out there. And then during the summer, we got it down to about 1 to 250, let's say. I think it was about what it averaged. So we had about 8 or 9 spots that we're testing, going back on GPS points to look at it. And it's different parts of the field, different soil types. And then the fall, when we just got the results back, we're kind of back up to 1 to 500. So somehow the bacteria slowed down, I guess, when the season cooled down.
That's
And
fascinating. Did you do any of that testing where BioCoat Gold had been applied?
uh, I haven't seen those results. So basically, where we had the seed treatment trials where Biocoat Gold was. Uh, we have that mark because we're going to go come back and look for legacy work there. And so we're also doing stubble digesters there. We have a treated and untreated area going one way with those products where we planted the other direction with the seed treatments. And so we're going to look for legacy effects. And those areas were sampled, John, but I don't have that data yet.
Yep.
And so
Awesome.
it'll be interesting to see what happens. So we can look at legacy effect. We can look at how things have changed on that farm over time.
Well, what you described about your observations around BioCoat Gold are interesting because we do see a lot of yield responses from that, particularly on corn. And but yet you are seeing it more in terms of disease suppressiveness, which is quite fascinating because um, that it was something that I learned only, I don't know, 6, 7 years ago. Um, that a lot of disease infections, even those that manifest later on in the plant's life, they might not show up until corn plant is even at V10 or at the tasseling stage. Those infections very commonly happen in the first 2 weeks of a seedling's life, where they penetrate into the root system and they stay there and they don't dominate, they don't cause substantial observable disease until later on when the plant comes under more stress.
Mhm.
So if you were observing the presence of those other beneficial organisms that immediately colonize the emerging seedling, shut that off, I've got to believe that also shows up in yield in some ways as well at some point, and it certainly will have a legacy effect. But that's a fascinating observation.
I would also guess that the grain quality is also improving in those areas where versus the control, if you will. So in one question that I have that was text to me, and I guess a little kind of housekeeping here is that there are some questions that have come across, and if we don't get to them, we'll follow up and answer some of those at the end, or maybe in a series, depending on if they're corn related, then we can get Ed to answer some of them after the fact, or John, we can forward them across to you that you can get out to people that are viewing it. But the question that I have is why is there a difference in an ear and leaf disease when we omit the soluble upfront, maybe P and K, um, and focus on biological, say in furrow. Many people might not necessarily see a benefit to the in furrow. So how does the AEA approach? How is that different, and how does that bring ROI to the grower?
Well, the there's several dimensions of of your question there, Andrew. But the short version is that um, you cannot build grain when the plant's vascular system is collapsing. And historical agronomy has really focused on um, using nutrition management to drive yield with little or no consideration for plant health. And so the easy solution, if you want to have large kernel size and large grain size, is to pour on a lot of nitrogen and pour on a lot of potassium and so forth. And that works until you get the when you start getting diseases coming into the plant's vascular system, slowing down sugar flow. And what a lot of people don't realize in corn specifically, I'll answer another aspect of your question specifically for corn. The triggering of black layer and how early that happens is a function of, it is connected to a nutrition management. So if we have really strong cell membranes with very high calcium and silicon levels, and we don't have elevated levels of soluble forms of nitrogen moving into the grain, you can delay black layer by as much as 10 to 12 days. And that's pretty substantial because you're gaining several bushels per acre per day every day that you're delaying the black layer, which is essentially, I mean, black layer is essentially collapsing of those individual cells that can no longer stand up to the trigger pressure or to the external pressure, I should say. So I suppose to condense all of it down and bring it to a kind of a simple point is our agronomic approach at AEA is to say we want to achieve the highest yields possible that in synergy with biology and with nutritional balance. So the result is we take a slightly different framework and different point of view. Perhaps we use lower nitrogen levels corresponding to higher sulfur levels and higher zinc and cobalt levels, whatever the case might be. So we want to get to a plant where the grain is mature and has dried down, and the plant itself is still healthy and green and photosynthesizing. And that's when you get not just the highest yields, but also the highest quality, the lowest aflatoxin, and particularly over time, that this different type of system approach, this different type of thinking has cumulative legacy benefits where they begin compounding on itself, and your input costs to maintain that form of production drop off extremely rapidly after a couple of years. Does that make sense? Is that an answer to the question you were asking?
Yeah, I think so. So with that being said, and that answer, then I guess would lead me to wonder if there was a John Kempf corn protocol from start to finish. What would be your blueprint for a season of corn?
Tortillas. Um,
No argument here. So,
um, so there is a base blueprint. There's a base protocol that we've put together. There's lots of logic behind it, where we're looking at different nutrient applications or different nutritional requirements at different stages of plant growth. But of course, all of that is designed to be adapted to local context. But I think
Sure.
at its most fundamental level, I would put it like this way. I put it in this way. First, we begin with a microbial inoculant as a seed treatment. It's one of the least expensive things you can do on a per acre basis with the greatest ROI. Second, look at a starter application that does not compromise that biology. And I think just very broadly, when I look at the industry as a whole, there are now 1,001 microbial inoculants and biostimulants on the marketplace with all
Mhm.
kinds of variability and effectiveness. But a major challenge for why many of these products have variable performance is, well, I shouldn't say it quite in that way, but many of these products aren't put in a position to succeed.
Right.
If you put a mycorrhizal inoculant on a seed and apply 4 gallons of 1034O on top of it, you shouldn't expect to see a response because the 1034O just turned it into toast.
Mhm.
So it's the combination of an inoculant, a starter solution that is microbially friendly, and then I usually prefer side dress nitrogen applications, or let me say it this way. I prefer to manage nitrogen applications in such a way that we do not provide 1 megadose of excessive electrolytes in close proximity to the root system all at one time. If we do, I prefer to do split applications, multiple applications per season, whatever fits the context.
Yeah. One of the questions that came up in the chat was, your thoughts on a foliar application of nitrogen in season and what that. I guess I could read the question exact. Yeah, so there's another one out here and you can answer this while I'm looking for this one question, John. It was if the seed maybe it came from someone else outside of us where they didn't have the option of getting it untreated or put with BioCoat Gold on it, how does the BioCoat Gold on a seed that might have fungicide, insecticide on it, is there, a battle going on that seed, and then what does that look like for its performance moving forward?
That's a great question, and it's one that I had a good friend of mine, an agronomist in Minnesota, looked at it this last year in quite some detail. And uh, see, BioCoat Gold contains mycorrhizal fungi, but BioCoat Gold is not just mycorrhizal fungi. We have quite a diverse collection of bacterial inoculants in there as well. And so what I found so intriguing, so supposedly, according to research in the literature, there are some fungicides that are quite benign to mycorrhizal fungi and others that have much more of an impact. But even in spite of that, in the research that Joe did in Minnesota, the BioCoat Gold on fungicide treated seed still showed effective colonization, which don't ask me how that works. So I don't have an explanation for that other than the fungicides are not directly impacting the mycorrhizal fungi. So we've done from a very practical, experiential perspective, BioCoat Gold gets put out there on many, many, many acres and mostly on treated seed at this point with generally positive effects. So what exactly is going on there? Is some of those effects coming from the bacteria instead of the fungi? Are the bacteria neutralizing the fungicide so that it doesn't have the same degree of negative impact? I don't have answers at this point, but it happens. I don't know, it's kind of almost standard practice.
So, John, do you see any difference with biological products applied to seed based on what the previous crop was? How, and I'm just looking at it from a corn perspective from data that I've seen is that when we go into a corn on corn environment, we believe that to be a little bit rougher than a corn and soybean rotation. And right now, I just at the data I have in front of me, it's looking like the biology struggled a little bit versus the naked seed and corn following corn. But when we get into it, let's say more standard rotation like corn and soybeans, it was very neutral to positive with the biological seed, coating applied. Now, the caveat I'll lay in, or go ahead and finish, then I'll tell you something a
No,
little
go
bit.
ahead.
Okay, so then the only caveat I'll say is the corn variety that we did this testing with was developed without any seed treatments through its life, so it may have something else going on that might be messing up the results for the biology. Why the untreated is going higher than maybe the treated on these like say like in the corn on corn segment.
You know, Ed, I'm really I'm I'm very intrigued by the momentum and the shift in direction that you might have in your breeding approach, and and the different outcomes you might have. I'll tell you a story about. I was kind of not directly involved, but just a distant secondhand observer. Years ago, Gary Zimmer had from Midwestern BioAg at the time had conversations with Cal West Seed about their alfalfa seed production. Said, "Hey, we would like for you to develop some alfalfa seed that is adapted to our biological type program, generous levels of soil calcium and cover crops and manure incorporation and building up soil organic matter." And so they took that approach and they developed several different alfalfa varieties, but there was this one stellar performer that they called Winter King. And Winter King, it turned out, was an exceptional performer, not just in the biological systems, but also in the non-biological systems. To such a degree, they continued developing and breeding that line, eventually developed Winter King 2, and I think they're now on Winter King 3, if I'm not mistaken. And it was such an overperformer that it has become a significant part of their line because it outperforms in both biological and conventional systems because of its collaboration with biology. And I'm really curious if you might not see something similar emerge with your corn genetics.
Well, you kind of, I was going to bring up Winter King because I heard it on one of your podcasts'
Yep.
story. And so um, I I think about this stuff a lot. How do you direct your breeding program? I mean, I think we've been breeding for regenerative ag for 20 years, but didn't realize it because I like high stress. I'm kind of a student of Norman Borlaug and shuttle breeding, and you got to apply the stresses that you want in every generation so that you have the most stress tolerant possible crop when you finish the variety and you get it out into commercial conditions. And so I was thinking, so if, and we've done a lot of our high stress work here in Puerto Rico where the soils are uh, they've been abused for a long time with glyphosate, excessive tillage, high sunlight, high heat, so that whatever biology we have there, and we do have some, it's been beat up. But this is what we do our corn development on, and so then on top of that, I apply. Um, I don't apply any insecticides for insects. I want the insects to beat up the corn. I want, because I want native insect tolerance. I don't. We reduce the water to the point where it just barely survives. And so we kind of got it dialed in over the last 100 crops I've raised down here now. And because I can do about 3.5 a year here, continuously cycling and stuff. And so when I heard about Snow King, I thought, gosh, if I improve my soil here and up in Minnesota, am I going to remove my ability to select genetics that like stress? Because I really believe these products farm the microbes they want in that soil. They wake them up or they do something during that crop. And so if I put this into a very healthy soil, do I go backwards with my breeding program? That is the one question I have. But the Winter King story gives me hope that maybe I should go that direction and even have
Yeah.
stronger products. I don't know.
So, Ed, we could really go down a couple of earthworm holes with this topic because I've thought about this a lot. If you would have asked me the question 10, 15 years ago about the influences of plant stress on a crop, my perspective at that point would have been, this is not from a breeding perspective, but from a crop production perspective,
Yep.
my perspective would have been that we want to do everything possible to minimize stress and to remove stress from a crop. We want it at peak efficiency, peak photosynthesis. We want to limit stress as much as possible.
Mhm.
But I've changed my opinion about that. I've changed my perspective. And I've come to the conclusion that different, as you know, different types of stresses will have different phytohormonal impacts. And there are specific types of stress at specific stages of plant development that can be incredibly beneficial from a yield perspective and from an immunity perspective as well. So It's and there's lots of variables and variation.
Mhm.
It'd be a fun conversation to dig into, but the greatest crop responses, the highest performing crops, with the highest quality markers, are those that are grown on well balanced soils and stressed.
Intriguing.
Yeah.
Um, we get a lot of time involved or stuck into developing a variety. I mean, we spend more time with them than we do our kids. That's why we name our hybrids, girls' names because I mean we're so intimate. Knowledge, or, raising them up, help them develop it. Uh, that we got 10 years involved roughly from the product concept to commercialization in a grower's field. So and you don't want to make abrupt changes to your breeding program without really solid reasons. But I'll say that we started out with high stress, and now I've added no-till for our breeding nurseries up in the Midwest, cover crops in the fall. Last year, I even did interseeding. I've been scolded from my breeding team not to do that. Okay, so the top So this is out of our germinator, just wrapped in a cold towel, or and germinated in a warm germ. I think for about 7 days at 75 degrees. So this is untreated seed. It's the same variety, but it's grown under, let's say, the beginning of a regenerative system, the top one, and the bottom one was grown in a um, let's say more commercial setting where fungicides were used. And it's the same variety. It's not been developed in our system. This is a third-party product. But look at how much more fungal attack is where it was grown in a more standard field,
Yep.
where the above one was grown into a field that had been strip tilled for 3 years, no seed treatment applied, and no fungicide applied during the growing season.
That's the important part. No fungicide
Yep.
applied during the growing season because now
Yep.
you have a much richer microbiome.
Yeah, but just look at the difference. So the bottom slide is probably why we need fungicides on our seed.
Yeah, that's incredible. That's an incredible difference.
I mean, you don't expect this stuff. It's the same variety. I would attribute it to the genetics, not knowing the background here, that one was more resistant to the fungal.
Hmm.
But it's things like this that's really dramatic. And then here's
So
another slide. Oh, go ahead.
just on that, you are, as far as I know, one of the few corn seed companies that are actively working on this. And when you think about what this means for the way that you are growing your corn, that is where the seed is going to the grower compared to commercial production,
Mhm.
that's a dramatic difference in quality as a result of the growing process and the environment that it's grown in.
Yeah, it's surprising us. I mean, we're also looking at uh, various products on a hybrid by hybrid basis on genetics then as well. Because I would like to get to the point that we know that Biocoat Gold work on these varieties, but it might be antagonistic on these varieties, to try and get our recommendations like that, based on genetic background.
So two thoughts. One is you've been experimenting with Biocoat Gold, and I made this comment at the beginning. Like Biocoat Gold has been, it's just a high horsepower product for us. It probably gets used on more acres than almost any other AEA product.
Hmm.
But we're constantly evolving, and we have a generation two of Biocoat Gold in the pipeline that I want people to be thinking about because it's not going to be ready for widespread use this spring. It'll be next growing season. But oh my goodness, is it going to give us some nice surprises?
Yeah, that's the fun stuff. It's all evolving when you deal with living organisms. I mean, everything keeps evolving. And so with this slide here, to kind of continue our discussion, is the slide on the right was seed produced in 2025. And it's a brand new inbred line for us. It's moving forward on multiple hybrids. We'll probably be able to commercially release this hybrids on this inbred line probably by 2028. So we're this far back in the pipeline, but what happens is, okay, it's progressing, it's showing us high yield. We want to cross it across more other inbreds to see if we can create more hybrids with this inbred line. Well, of course, we needed more seed than we produced in 2025. And so we wanted to go back, we can go back each year and collect inbred seed from previous generations. And so on the left side, that seed was grown in 2023. That was the first year that I planted no-till into a winter-killed cover crop. And then the next year, I decided I'm going to go no-till again into a winter-killed cover crop. And then in 2025 on the right, that was again a winter-killed cover crop, but I pre-seeded with my oats and peas and I don't know, something else in there, buckwheat, I think. And then this is a seed harvested from that. But that's 3 years of no-till, 3 years of winter-killed cover crop. And you can see the color get darker as you go to the right. When we went and pulled the 2023 seed out, we thought we had the wrong ear selection. It was that much different, or lighter in color. And so then we did this across several other inbreds to make sure this was a change that was happening because of the way we were changing our farming practices. I found this incredible.
Awesome.
And
Love it.
uh, and so that uh, I guess I just wanted to show that to you and let you see that. I hope my share stopped. Um,
Yes, it
Yep.
did.
and just to get your opinion on that, because that was just 3 years of no-till and 3 years of cover crop in the fall, winter killed cover crop. So it never got more than maybe 4 to 6 inches tall in the fall, the wheat that I planted or barley. And that was the only changes other than I even used herbicides. So it did, I mean, there I can't even say that, but it's always untreated seed. And that was the
Did you
difference with the,
did you use fungicide?
no, I don't use any fungicides either.
Yeah.
And I mean, because we're always looking for native disease tolerance. So if I put a fungicide on, that ruins it for us. We want to make sure we get to select. I'm the only guy that wants to have diseases come in the fall in Renville County, Minnesota, and because I can make selections against. I don't mind having drought. If it was just on my farm, I'll take the drought. That's fine. And so because I think we make advancements and but I just see those changes happening because so this kind of leads to a topic I want to explore with you a little bit, John, is that in I think maybe it was at Acres you might have said that you have a goal of regenerative agriculture on like 80% of the acres by 2040. And I mean, like, we really want to figure out how we can help you with that or work with that to get there. But I want to do it faster. I'm older than you are, and I want to see it.
Yeah, well, 2040 is only 15 years away anymore.
Yeah, yeah. Uh, it happens
Yeah.
quick, but I mean, with corn being a large chunk of these agricultural acres and probably one of the largest users of inputs, I mean, it's imperative to our group that we understand how fast can we take a guy who's farming the big ag way and get him on the regenerative ag path quickly and be profitable every step of the way. And so that's why we're playing around on the edges with, seed treatments, biology, what applications can we reduce nitrogen? Because I mean, creeks and lakes that I grew up, I could swim in. I would not swim in them right now.
Yeah.
And all we have to do is look in the mirror. Who caused the problem in agriculture?
Yeah. Yeah, exactly. Well said. Um, I think, look, Ed, I'm really excited to be having this conversation, but I see so much potential and so much opportunity in the work that you're doing from a selection and breeding perspective that, um, well, let me back up just a bit. You know, there's a very different domain of breeding work in apples. Of course, apples have this incredible genetic diversity. Apples and tomatoes are, I think, must be close to the top of the list of the genetic diversity that they have. Um, but if you go back in history, 200 years ago, they put apple varieties into two distinct categories, and I forget exactly what they called them. The second category was a filler, and I forget what the name was for the first category, but the designation was that they were expected to be a multi-generational tree. You planted
Mhm.
a tree once, and this tree was expected to last for generations. And so when they were planting commercial orchards back in the early 1800s, they were describing this technique. They would plant these lifetime trees at quite some distance apart, and then they would plant in filler trees in between. And the expectation was that these filler trees, they knew that they were only going to last 15 to 20 years lifetime. That was as much life as those trees had. Those multi-generational trees would then fill in the space, and those trees had characteristics that they were specifically selected for, and they had specific breeding work done on them. They were triploids instead of diploids, and they were incredibly disease resilient. They were very robust. They lived forever. And all of that breeding work, that approach of specifically developing triploid apple varieties, has just been ignored. When fungicides came along, we had an easy button for disease control, and the
Mhm.
easy button replaced the need for 20 or 30 years of painstaking research work and breeding work. And but what has happened now is that some of those older genetics are still to this day the most robust parent genetic material for disease resistance. And so I consider the work that you are doing, in the breeding approach that you are taking, is establishing a foundation for commercial corn production from a very different, I don't know quite how to frame it, a very different disease resistance perspective, just a very different resilience perspective with lower input costs that can completely displace, or I should say supersede and outperform, the genetics that are commonly available and so widely being used today. And I'm quite excited about that.
Yeah, it's really exciting to see the products performing to keep up with what's out there currently. Supposedly the best stuff out there, with all the GMO traits in it. And I mean, John, originally my job when we first moved to Puerto Rico was to bring those GMO traits into corn, and and we did pretty well at it. But it got to a point where I don't see how this is helping us as a in a crop. Um, and that's why we started down the path we started down 21 years ago now, is just because there had to be a different way, because I started seeing native insect tolerance. That's what started this whole idea, was native insect tolerance, and to be refuge corn for the BT corn. That was the idea. Well, once they put in glyphosate, that took us out. And one thing in the corn business, so like when I started out, I wanted to convert our corn to glyphosate tolerant, because then we could get on the acres. But when it came time to sign the agreement to do that, then the company that originated that trait controlled my
Right.
inbred, my corn genetics. They told me if I could sell it or not, the hybrid.
Yep.
They had that much control, and that was one gene out of 55,000.
Right.
I didn't think that was fair. So that's when we made our decision, no more GMOs, because I don't want that control. We want to be more flexible in what we do, and have a global impact instead of just a US impact.
Well, I think what is intriguing, I don't spend a ton of time on social media, but I pay attention a little bit. And there's been, just in the last year, there's been all of this chatter online about growers who are testing, and it's been ongoing for years, but they're running side by side comparisons of the same genetics, GM versus non-GM, and they're observing a very noticeable yield drag from the genetically modified varieties. And you're saying, well, at the current economics, the current price points, it just doesn't make sense anymore, and they're moving away from GM selections.
Well, and this is one of the reasons why we went out on our own, John, is the fact that since the beginning, when I started working on this, we always saw yield drag with the GMO gene in
Yep,
absence of the pest.
exactly.
When the pest was there, then it out yielded. In the absence, it was always a yield drag. And I firmly believe that's why refuge in a bag showed up, because when combine monitors came out where guys could measure their refuge corn against their GMO corn, they were seeing the refuge corn outperforming it. And that's all of a sudden, I mean, that might be my conspiracy tin hat moment, but it's amazing how close that happened is refuge in a bag and combine monitors becoming an everyday practice. So
Intriguing. That's
yeah.
intriguing.
I can wear a tinfoil hat with the best of them. So
Sounds like some more earthworm holes we could go down.
yeah, yeah, exactly, exactly. Uh, it, but it's just things, like we're trying to figure out ways to measure and improve our farm. So we take a lot of bricks readings and stuff, especially here in Puerto Rico. And I watched a couple podcasts for this gentleman down in Florida looking at GMO soybeans versus non-GMO soybeans. He can't get the bricks high on his GMO beans
Hmm.
and on his non-GMO beans. So I can see the same thing here in Puerto Rico. I'm having trouble getting bricks over in my GMO corn day because I'm under high insect pressure here. And if I can get above, 12, my fall armyworm problem goes away. Well, I'm having trouble getting the GMO corn over 6. But I'm starting to get the corn that we've developed now between 10 and 15. But it goes up and down based on the time of day and weather.
I had this intriguing experience years ago on a tomato greenhouse where they had three different varieties side by side in the same tunnel. One was a very modern greenhouse cultivar, the other was a couple decades old field cultivar, and the third was multi decades old, considered heirloom variety. And as the season progressed and as they were managing nutrition across those three varieties, was a consistent 2 point Brix difference between A, B, and C, where
Mhm.
if the most modern selection had a Brix reading of 3, the couple decades old field variety would have a Brix reading of 5, and the heirloom would have a Brix reading of 7. And they went up and down together. They consistently stayed 2 points apart all season long. So there is, again, Ed, this is such exciting work that you are doing because you can select for the ability for nutritional absorption and health, and there's this microbiome foundation that is such a crucial part of it.
Yeah, and it's exciting. Then trying to figure out how we, you know, not only develop the seed, but produce and manage the seed so that we can deliver the best package to the farmer possible,
Yeah.
where we can help improve his soil then. That's where I think a little bit of the whole, how do we change from current farming practices to more soil health and regenerative ag practices? It still starts with the seed. Maybe that's a old metaphor because I'm a seed guy, but I think that's where it starts first, the seed, and then we can build around it. And
Well, the beauty of what you're doing, Ed, is that well, I'll just put it into a BioCode Gold metaphor. Is that as with BioCode Gold has been such a heavy hitter and so effective for so long. But there are now soils that have regenerated and that are microbially healthy to the point where BioCode Gold doesn't show as significant an impact anymore.
Mhm.
So that actually provides an impetus for us to generate to develop a second generation product that now can take that to the next level with everything else that we have learned. And there is a sense still for which BioCode Gold is a band aid for poor quality or seed that is produced in a poor quality microbiome
Mhm.
or seed that is placed into soil with a poor quality microbiome. I fully expect that if as your the biology contained within and on your seed continues to improve and growers plant that into optimally healthy soil, I mean, the objective and the goal should be to get to a point where there are no additional further benefits from BioCo Gold because the overall ecosystem, both the origin and the planting location, is in such awesome condition.
And at the same time, that mean no synthetic inputs either. The soil is doing what it needs to do, other than maybe we need to add a few minerals,
Yeah.
from rock dust or something. So,
Or perhaps, I mean, I'm not opposed. As I think about this, there are in an agricultural setting in high yield environments, um, I do find the use of some what's the appropriate term? Um, Touch points or leverage points. So many uh, microbial processes and plant growth processes respond to disequilibrium. You don't want the pendulum to just stay hanging in one place. You want it swinging back and forth because that energy release from the movement back and forth is where you get energy, momentum, and growth from. So sometimes applying a microbial inoculant or applying a fertilizer in small amounts, and this is the interesting thing, is that as an ecosystem health improves, you can apply small amounts of something just to push the pendulum and to get the system to move and to react more, and then you get more growth out of it. So I'm not entirely of the opinion that we should desire to get to a point where we have no inputs, but that those inputs should be very small, very judicious, timely, and produce large responses.
so what do you think about maybe more enzymatic or hormonal
Exactly.
pushes
Those are
rather than chemistry?
exactly. Those are the types of things I'm talking about.
Okay,
Yeah.
because that's really intriguing as well as we keep digging into this. What where do we go? How do we keep pushing and have the healthy environment I want to have for our grandkids? That's the driver. It really is. So,
Well, we need to sit down and chat some more. We have lots of things to follow up and to talk about.
oh yeah, I've got a ton more questions in my notebook here, and I suspect you've got other things to do, but I'm thoroughly enjoying myself today. Thank you, John.
Yeah,
You're
so
very
I'll
welcome.
add a few things here is that anyone that's watching or paying any attention is that us at Bass we are a distributor for AEA products. So if there's anyone that wants some questions answered or their hands on some of it to give it a try, definitely reach out to us and we can help facilitate that deal. Um,
May I add to that,
yeah.
Andrew? Yeah, we're very enthused about our developing relationship with Bass hybrids and particularly the ability for you to treat seeds with BioCoat Golden Seed Flare. And we haven't formally announced this yet. I suppose I'll make a kind of an introduction here because I've posted it on social media a bit. But we are actively working on putting together a performance warranty for BioCode Gold that you
Oh,
apply it. There's certain parameters of treated versus untreated areas that are a part of the deal. And if it doesn't perform, if it doesn't produce a response for you, you get a 100% refund. We have so much experience with it. It's such a robust performer. We're confident in putting that together. So the details of that are still being finalized and will be released here within, I would expect, within the next week or two.
That's awesome. Put your money where your mouth is, right? That's good. And I'm certain that if people are putting this into play, that there'll be definitely a positive impact on uh, not only the crop that year, but the legacy effect that's going to happen in that soil and around their entire operation. Um, well, I do have one question, in and then we can leave it at that, or if you have other things that
got
you
one
want
question too, Andrew. So,
Okay, yeah, yeah, sure, sure. So, at Acres, you had mentioned, there was a conversation that you were in and talking about Peter Thiel, talking about, okay, well, if someone has a 10-year plan,
Mm.
how do we, you know, how do we do that in 6 months? Okay, so if our plan is, and you've also been noted to say that we would love to see the adoption of some of these things be broadacre by 2035, 2040. So call it 2035, and that's 10 years. So taking that message that you said about talking to an entrepreneur about making that happen in 6 months, how do we make it happen in terms of a regenerative landscape in one season? And I guess that could be a two-part question really is how or what steps would, to take maybe a commodity production specialist into a more regenerative minded operation. And then what steps would have to happen to make that 2035, 2040 goal happen in that, one season time frame.
Yeah. My goodness, Andrew, you go straight for the jugular here. Um, so The inspiration or the rationale behind Peter Thiel's question is if you had to, it's essentially if you had to accomplish your 10-year goals in 6 months, how would you do it?
Sure.
And it's a valuable question because it forces you to think differently. To
Yeah.
achieve 10 years worth of progress in 6 months, you can't just do the same thing faster. You
Right.
have to do something different. And
I think it weeds out some of the noise also of the steps that might you might be thinking that aren't necessarily necessary.
right. Um, and so on an individual, if I understood your framing correctly, you asked the question and kind of at two levels. One is at the
Sure.
individual farm level and on a kind of a macro whole ecosystem
Yeah.
level. Um, and at an individual farm level, um, I I have the benefit, of course, now of having a couple decades of experience and having been in this space.
Sure.
I'm entirely comfortable taking a farm from very heavy inputs to greatly reduced inputs in the first year, all based on good data. I would not shoot from the hip in doing that,
Sure.
but using soil analysis and tissue or sap analysis data, making sure that we manage that very well. And I'm very confident in doing that and not observing any yield losses or anything like that. Um, and I don't know if that quite fully answers
Yeah,
the
I
first.
think so. Yeah. Well enough. Yeah.
And on the second level, uh, doing it at a macro scale, you know, Charles Walters used to have this saying: people leave their senses as a group, and they come to their senses one at a time. We saw that during COVID, didn't we?
Yes.
um, but I think the kind of the preliminary question that has to be asked is what would have to be true for a majority of the farmers and growers in the country or in the world to want to or to have the desire to make that change. Because the reality is today, many don't have that desire. And you know, if you look at the historical pattern, many of the innovators in the regen ag space came to that space as a result of quite substantial pain, financial pain,
Yep.
family health challenges, something that triggered them to go in a different direction. And the farmers here in the U.S., the crop farmers, now they would argue with me, or this might be a debate, but you could make the argument that they are not allowed to feel pain. They have a kind of low risk backing and guarantees because yeah. Anyway, that's I don't need to go into that whole conversation in detail, but with all of the government support, so there is the question, I think, of what is the political will and how long will that degree of governmental support continue? And as saddening as it is to say it, perhaps with significant pain will come significant change. I
Sure.
guess we'll see how the future evolves.
That was a great answer,
Yeah,
John.
my
Thank
question was way easier, way easier. I guess I never thought of it, but for my interseeded cover crops, I'm going to put on next spring. Should I put BioCode Gold on that?
Yes,
Okay, see how easy that was?
you.
yes. And what will
No,
happen, um, just to elaborate on that answer for a little bit, um, I learned this from Dr. White. The the first 10 to 14 days after germination is when you have very rapid emergence of that radical. And it's often when that's the stage when the microbiome that is in or on the seed kind of races to catch up and to colonize that root system as rapidly as it is expanding. And it's often in that window when the native soil microbiome gets recruited or begins feeding on sugars and root exudates and begins colonizing that root system. And it's often at that stage where potential diseases establish their first foothold and first establish, first succeed in colonizing the root system. So if you can change the microbiome of the cover crops that are there, and have that be a disease suppressive microbiome and already suppress the presence of those potential diseases, two things will happen. First, the seedling will be much more readily able to recruit from that bulk soil microbiome, but also you'll kind of have preemptive disease suppression from that as well.
Yeah, so that leads me down another one, and so I'm really thinking that there's so much microbiology we don't understand. And I think you made a statement, or one of your guests in one of your podcasts made a statement that good biology always wins over bad biology. And maybe the simplest thing we can do is feed the biology that's in our
Yes.
soil above anything else.
Yes, I don't remember who made that comment. Actually, I may have heard it off podcast first and then repeated it. I don't remember exactly, but I do remember just being surprised. Um, what was relayed to me in essence was that if you provide an abundant food source, the good guys always win.
Yep.
Hmm.
And of course, the best food source is root exudates from green photosynthesizing plants.
Hmm. Yeah,
Absolutely.
and I don't know, it's just opening up so many more topics here.
Well, let's do this again sometime soon.
I
Yeah,
would love to.
absolutely.
Thank you. Thank
I'll
you. I
volunteer
really
for that.
appreciate you spending your time with us and talking with on the Basscast here. We do appreciate that very much.
Yeah, for sure.
Well,
And I know we definitely left a lot of meat on that bone, and there's a lot of questions here, and you know, and I have all of the questions here, and it'll save everything for me. So, like I said, some of the ones that are corn related, you know, Ed and I can get on top of that, and then answer those, and have some of those posted on online in different spaces, and John, I'll make sure that that Jeff or Phil get some of the
send
questions that might be, you know, more related to what you have over to you. Then, you know, we can continue the forum and answer those questions and. You know, because then we'll have this being recorded, so we'll be able to replay this and have some of those maybe answered in the comments or something. But John, I really appreciate your time and then all of the efforts you do as you know just you know a very vocal person in the landscape of all of these things related.
he had a lot of heartburn. He had a lot of heartburn in the last 60 seconds.
Yeah, he looked
So,
nervous. The show
well,
went
good
on
to
without
have
you, Andrew.
you.
We did good.
I figured it would, and it'd keep recording. And I guess that's the you know the downside of living out in the country is that sometimes the you know the internet connection is not as strong as you'd like it to be. But you know what I said when I froze up was the most important thing that anyone has ever said in the history of agriculture. No, I kid, of course. Well, I was just basically saying thank you, John, for all of the effort that you put out there and being a vocal leader in kind of a regenerative movement. I don't even like calling it a movement, really. So. Once again, it's nice having your voice here on with us, and I truly appreciate it. So thank you very, very much for being a part of this. And like I said, we left a lot of meat on that bone. I think there's a lot of questions that can be answered, and if we can do it again anytime, we're up for it.
Let's make it happen. Thank you
All
all.
right,
Have an
thank
awesome
you.
day.
Take care.
Thank you,
Yep,
guys.
thanks everybody out there. Yep, bye.
Bye.